Hello, in this lesson we will study two-variable linear systems. We will focus on solving systems using the method of elimination, interpreting solutions graphically, and understanding what different types of solutions tell us about the relationship between two lines. Let's get started. In this section we will learn three important ideas. First, we will use the method of elimination to solve systems of linear equations in two variables. Second, we will interpret graphically the number of solutions a system may have. Finally, we will apply systems of linear equations to solve real-world problems. By the end of the lesson, you should be comfortable determining whether a system has one solution, no solution, or infinitely many solutions. In the previous section, we studied the methods of substitution and graphing. Now we introduce another powerful technique called the method of elimination. The basic idea is simple. We manipulate the equations so that one variable has coefficients that are opposites. We then add the equations together. That variable disappears, leaving us with an equation in only one variable. The elimination process consists of 5 steps. First, obtain coefficients for one variable that differ only in sign. Second, add the equations to eliminate that variable. Third, solve the resulting equation. Fourth, substitute that value back into one of the original equations to find the remaining variable. And finally, check the solution in both equations. Many students find elimination faster than substitution when the coefficients are easy to manipulate. Let's solve this system. 3x plus 2y is equal to 4, and 5x minus 2y is equal to 12. Notice that the coefficients of y are already opposites. Because 2y and minus 2y cancel when added, we simply add the equations, and this gives us 8x is equal to 16. Dividing by 8 gives x is equal to 2. Next, substitute x is equal to 2 into equation 1, and we obtain 3 times 2 plus 2y is equal to 4. That means we get 6 plus 2y is equal to 4. 2y is equal to negative 2, thus y is equal to negative 1. Therefore, the solution is 2, negative 1. We verify by substituting the ordered pair back into both original equations. Since the ordered pair satisfies both equations, our solution is correct. Now consider this system. 2x minus 4y is equal to negative 7, and 5x plus y is equal to minus 1. In this example, the coefficients of y are not opposites. To create opposite coefficients, multiply equation 2 by 4. This produces 20x plus 40y is equal to minus 4. Now the 4y and the minus 4y terms cancel when we add the equations. Adding gives 22x is equal to minus 11, and dividing by 22 gives us x is equal to minus 1/2. Substituting this back into equation 1 gives us 2 times minus 1/2 minus 4y is equal to minus 7. That means we get minus y minus 4y is equal to minus 7, and negative 4y is equal to minus 6, thus y is equal to 3/2. Therefore, the solution is minus 1/2, 3/2. As always, substitute the solution into both equations to verify the result. A system of two linear equations can have three possible outcomes. The first possibility is exactly one solution. Graphically, this occurs when two lines intersect at a single point. Because the slopes are different, the lines eventually cross. The second possibility is infinitely many solutions. This happens when the equations represent the exact same line. Every point on one line is also on the other line. And the third possibility is no solution. This occurs when the lines are parallel. Parallel lines never intersect because they have the same slope but different intercepts. Understanding these graphical interpretations help us recognize what algebraic results mean. Now let's solve this system. X minus 2y is equal to 3, and minus 2x plus 4y is equal to 1. Multiply equation 1 by 2, and this gives us 2x minus 4y is equal to 6. Now add the equations. The variables cancel, leaving 0 is equal to 7. This statement is impossible. Because a false statement results, the system has no solution. We say the system is inconsistent. Graphically, the two equations represent parallel lines. Since parallel lines never intersect, there is no ordered pair that satisfies both equations. Now consider this system. 2x minus y is equal to 1, and 4x minus 2y is equal to 2. Multiply equations 1 by -2. After doing so, adding the equations produces 0 is equal to 0. Unlike the previous example, this statement is always true. A true statement such as 0 equals 0 indicates the two equations are equivalent. They describe the same line. Therefore, every point on the line satisfies both equations. The system has infinitely many solutions. We say the system is consistent and dependent. Graphically, the two lines coincide exactly. This concludes our lesson on two-variable linear systems. In this section, we learned how to solve systems of linear equations using the method of elimination, how to recognize systems with one solution, no solution, or infinitely many solutions, and how to interpret these results graphically. Be sure to practice several elimination problems on your own, especially those that require multiplying one or both equations before eliminating a variable. Thank you for watching, and I'll see you in the next lesson.